Hello viewers watching this video, and a special welcome to the pilot trainees. And as you know, we have been carrying out a series of lessons, and the topic today is atmospheric stability or instability. Welcome to my channel, Booty Aviation Training. Have you ever experienced being tossed up and down in the air, and some of you hitting the aircraft roof, called turbulence? What is severe turbulence? Turbulence, or kind category moderate, severe, etc. When you enter a parcel of air which is rising up, and then come out of it and enter a parcel of air which is under subsidence, being thrown downwards, the aircraft is also thrown up and down. Well, let's understand the reasons for it. Don't blame the pilot, and just understand the atmosphere. And there are nowadays aids available which are warning the pilots about turbulence ahead. Right. Sometimes you must have noticed passengers are asked to fasten seat belts, that we are likely to encounter turbulence. Good. How does it happen? And the topic is stability or instability of the air. What is stability in real life also? If a person suffers a disturbing force, could be death of a close relative, friend. Well, add to the list break up with your boyfriend or girlfriend, losses, financial losses. These are some of the disturbing forces in life, and many more. And some people recover from it fast, okay? And some are unable to recover, and they say, they go up the hill and their behavior changes. They are unable to come back to their original lifestyle, okay? And the person who quickly recovers and comes back to original lifestyle is called a stable person. And a person who goes about either harming himself or the other person is called unstable person. Similarly, in the atmosphere, if a parcel of air has got disturbed, after being disturbed, once a disturbing force is removed, if it comes back to its original position, it is called a stable parcel of air. If it continues upwards in the disturbed direction, unstable or negatively stable. If it does not come back to the original position but does not also continue in the direction of disturbance, it is called neutral stability. Right? Why should a parcel of air rise? What is the disturbing force? Number one, terrain, hills, or high ground on the way when the parcel is moving. So this parcel of moving, if it is moving in this direction here, and it encounters high ground or the hill, it will rise. After this, does it continue rising, or does it come back to its original position, either this side or this side? That is known as stability. It returns to its original position. The temperature around this parcel is cooler and this air parcel is warmer compared to neighboring parcels, then warmer parcel will rise. This place has got a lower pressure compared to the neighboring parcels of air. This parcel will rise. Turbulence in the hilly areas, parcel is being thrown up and down, it will rise. Or a warm parcel of air, let's say moving in this direction, and it encounters cold parcel of air, right? Cold air being heavier, this warm parcel of air will rise. So now we know a parcel of air may rise. After that, does it possess stability or negative stability called instability, or will it become neutrally stable? It primarily depends upon what is known as the environmental lapse rate. Now, the parcel of air which is rising or falling, you may not be able to see unless, like, you can see the smoke. The color is different and you are able to identify the smoke, but a parcel of air rising, you will not be able to identify. Yes, you will identify it. It's a vertical development cloud. The cloud will be visible to you. And when you are entering into a vertical cloud, be prepared for turbulence. We will read much more about this in the lesson on clouds. What is the total or absolute atmosphere instability? When the environmental lapse rate, symbol R, is more than the dry adiabatic lapse rate, symbol RD, which in any case is more than SALR RS. We studied in last lesson, dry adiabatic lapse rate is 3 degrees per 1000 feet and saturated air lapse rate is 1.5 degrees per 1000 feet. Let's say this is a parcel of air in the environment in which they have recorded a very high lapse rate, more than 3 degrees, 4 degrees, 5 degrees per 1000 feet. Maybe up to a certain altitude, after that it may be reduced or even become negative. I'm talking about this layer of air in which there is a high environmental lapse rate. This parcel of air, due to any of these reasons, if it starts rising, it will cool. If it's a dry parcel, it will cool at the rate of DALR, dry adiabatic lapse rate, 3 degrees per 1000 feet. Environment is cooling faster around it. So that will remain cooler and this parcel will continue its rise being warmer till the environmental lapse rate changes and then the temperatures somewhere equalize. When this parcel of air gets saturated, now it will cool at the rate of only 1.5 degrees Celsius per 1000 feet, and then the lapse rate of even 2 degrees will be high because parcel is cooling at the rate of 1.5, so it will keep on climbing up. So a high environmental lapse rate in the atmosphere gives rise to the instability. And if the environmental lapse rate is very low, less than SALR of 1.5 degrees, less than that, which in any case is less than dry adiabatic lapse rate, if a parcel of air starts rising, it will cool faster than the environment and it will settle down, and when the temperatures become even less, it may come back to its original position or settle down at the new position. So it will have a low ELR, gives rise to absolute stability. And then there is a conditional stability of the atmosphere. when the environmental lapse rate is less than the dry adiabatic lapse rate, means less than 3 degrees, but it is more than 1.5 degrees. That is called conditional stability. Then dry parcel of rising parcel of air will be stable, but a saturated parcel of air which is rising will be unstable. Okay, now environmental lapse rate we had studied earlier. It depends upon the environmental conditions. During summers when the temperatures are high, environmental lapse rate is also high. During winters when the temperatures are low, environmental lapse rate will also be low. So when there is stability in the air, the visibility is poor due to fog, haze, etc. because the air is now stuck to the ground and it is not rising. When there is instability, parcel of air is rising, it will carry along with it all the impurities like dust, smoke, etc. Now, do you wonder why the fog and haze, smoke, etc. remain close to the ground during winter season, causing pollution? As far as the precipitation or the rainfall is concerned, in a stable air mass, the clouds which form will give you continuous rain or drizzle, but in an unstable air mass, vertical development clouds will occur and they generally give you showers. Clouds, stratiform and cubiform, this you will understand the difference between them when I cover the lesson on clouds and air currents in the air. Smooth air currents, and unstable air mass will give you turbulence. So this is known as the stability and instability of the air. The pilots need to know it fully. Other viewers may keep it in their mind that when they face the turbulence, okay, go with it. That's a nature. And you have entered into a rising or a falling parcel of air. Good luck, all the best, happy landings, happy flying to everyone.